Hey, welcome again. So what we have seen till now in multithreading, let's revise. So we have seen introduction to multithreading. What is multitasking? Two types of multithreading, important topic. So process-based multitasking and thread-based multitasking. Correct? The difference between them. Then we have seen the objective and areas of multithreading. Okay, if someone asks, just give these examples. What are threads? We have seen what are threads. Okay, a thread is an independent path of execution within a program. Okay, it is a path flow. It is a flow of execution and nothing else. What is defining a thread means how we can define threads. There are two ways. Important question. How many ways? Two ways. Extending a thread class, implementing a runnable interface. Then we have seen how we can extend. We have seen this code, we have implemented this code, and we have run this code also. Okay, we have seen these important points. This whole thing is done. What is the importance of start? Why don't we use run method directly? We have seen this also. Okay, what will happen if we overload the run method? What will happen if these are the important? Is it possible to overload the run method or not? So these are the answers. What is overriding of run method? We have seen this. What is overriding of start method? We have also seen this. Okay, and these are the important points in it. Heard of this in the previous 3 lectures as well. What is thread scheduler? Let's begin. So it is responsible for scheduling threads. I think it is clear from the name only. It is responsible for scheduling threads. That is, if multiple threads are waiting to get a chance of execution, then in which order they will be executed, it will be decided by thread scheduler. So for example, if T1, T2, T3 and T4 are waiting to be scheduled, so who will get the chance? Whether it will be round robin, that is, we have a time quantum. If you have seen OS, so you know what is round robin. Okay, whether it will be based on a priority, that is, if T1 priority is high, it will be scheduled first. Then if T2 priority is second, then it will be scheduled second. Or will it be FCFS? So for example, if T4 came first, so it will be scheduled. Then T3 came second, so it will be scheduled. That is first come first serve basis. Or it will be last come first serve basis. So algorithms are many. So it depends on the underlying algorithm which thread will be scheduled by the thread scheduler. Okay, next, it is a part of JVM. Algorithm used by thread scheduler varies from JVM to JVM. Therefore, order of execution varies. We have seen that the order of execution varies. Hence, there is no guarantee for exact output. You cannot get the exact output, but the point is, it is not actually important. The output in multi-threading is not important. What is important? The execution speed should increase. The important point is execution speed should increase, and it does increase because now the same process which would have run by a single thread, now maybe it is running by 3 threads simultaneously. So obviously the execution speed will increase. So this is thread scheduler. Okay, now we will see what is the life cycle of a thread, that is how many thread states are there. Okay, it is very similar to operating system because in there also we have seen what are process states, and the states are actually same. We have a new, ready or unable, blocked, waiting, time waiting, terminated. Okay, so these states are actually same. So let's see these states one by one now. So if I draw a diagram, so first it will be newborn. So when it will be newborn? So when I am creating that object, for example, child thread, CT equals to new child thread, correct? At this point of time, this will be newborn. Okay, at this point of time when I am creating the object of a child thread, then it is newborn. Then when I write ct.start, after I write ct.start, a new thread is created and it is ready, runnable. That is, it is ready to be running. Okay, then using the thread scheduler, if we have T1, T2, T3, T4 here, correct? So it will schedule a thread inside of it and it will give it to the CPU. Then the thread will start running. And when its job is complete, job is done, then it will be terminated. Okay, these are the 4 states. These are the 4 states. Now we have many more states, that is waiting state, block state, time waiting state. Okay, that we will see when we will see different functions, different methods of thread class, due to which method these states are required. Okay, for example, there is a method of wait, there is a method of join. So these states, there is a method of yield. So using these methods, the new states will be added in this same diagram. Okay, we will see one by one. Okay, but these are the 4 basic states. Now let's move forward with a theory. So what is a new thread? When you create a thread with a new operator, that is when you write this new child thread, correct? New child thread, then we have a new thread. The thread is not yet running. This means that it is in a new state. What is ready or unable? Once you invoke the start method, that is when you write ct.start. Okay, when you write ct.start, then from the new, the state changes to ready. Okay, Here the thread scheduler schedules thread for the execution so that each thread will get time to execute. So from the ready state we have a queue of thread schedulers, and we have a queue of threads, and from this queue the thread scheduler will choose one by one, depending upon the algorithm, which thread will be executed. Correct? Next point. So what are waiting threads? So when a thread waits for another thread to notify the scheduler of a condition, it enters into the waiting state. Okay. For example, if T1 is running and T2 is running, okay, and T1 wants the output of T2, so it will wait till T2 executes. Okay, it will wait till T2 executes. Then when T2 executes, it will notify that I am complete, so now you can use whatever data you needed. Okay, so we will see this in wait method also, in join method also. Okay, this happens by calling object.wait or thread.join method. Okay, we will see this in join method. So at this point my T1 will go to the waiting state. Okay, we will see this in join method. Then we will add a new waiting state in our diagram. Next is time waiting state. If T1 says that I will wait only for about 9 milliseconds, then a method will be used. You will see that afterwards. So several methods have a timeout parameter. Calling them causes the thread to enter a time waiting state. Means for only 9 milliseconds I will wait for your output. After that I will begin my execution. That what it says. Okay, so this state persists either until the timeout expires or the appropriate notification has been received. Okay, there are two cases, means whether 9 milliseconds is complete or T2 is complete and it gives the notification. In these two cases the T1 will start the execution. Fine. So this is time waiting state, and we will see this in very detail when we will see these other methods. Okay, next we can use thread.sleep method and time versions of other methods. This point will be very clear, these 2 points, that is waiting threads and time waiting threads, when we will actually see these methods, okay, in action. Next is terminated threads. So a thread is terminated for one of the 2 reasons. What are the 2 reasons? First, it does a natural death, means its job is completed. Second, it does abruptly because an uncaught exception, that is exception, an error, a runtime error, or a type of exception. We will see how many different types of exceptions, don't worry. So it dies abruptly because of an uncaught exception, terminates the run method. Okay, so whenever you have an exception ending, you have to throw it and you have to catch it, try and catch block, or you have to throw it. Okay, you have to handle that exception. If you are not handling an uncaught exception, then it may terminate the run method. So what was these? These were the threads. These were the states, the life cycle of a thread, from new, that is from born, to terminated, the whole life cycle of a thread. Correct? So this is a question. After starting a thread, if you are trying to start the same thread again, then what will happen? For example, if I have already started a thread, and if I want to start that thread again, okay, it is in a ready state, and I want to start that thread again, then what will happen? So it will give a runtime error. So you can write it down. It will give a runtime error, and the error is illegal thread state exception. Okay, if my thread is in, for example, if you are 10 years old and someone says you have to be born again, so there is an error, correct? So that error is nothing but illegal thread state exception. Okay, so this is an important question. So after starting a thread, if we are trying to start a thread again, so what will happen? So it will throw an exception. That exception is illegal thread state exception. Okay, so this was the topic of thread states. Okay, how many states are there? We will, in that diagram, we will join more states, we will add more states, correct? And what is a thread scheduler? What is a thread scheduler? We have seen in this video. Now from the next video, what we will see in the next video the second method to define a thread. Okay, now only a single method was defining a thread using what? Extending the thread class. Now we will see defining a thread by implementing or enable interface in the next video. Okay, thank you.